Hello again. We're going to take some notes on 6.3, parametric equations and motion. So up until this point, we've been representing a graph by a single equation that has two variables, x and y. Specifically, we say y is equal to f of x meaning y is a function of x, or as x changes, so does our y. However, in parametric equations, we are going to introduce, why is it doing this? Introduce a third variable known as t. So let me give you a brief example. I burn fairly easily in the sun. So I use a lot of sunscreen in the summer. This is a true fact. And I use less in the winter, even though technically you are supposed to still put it on in the winter as well, but I'm not standing outside as much, so I don't wear as much in the winter. Now, I also really like custard. Don't love ice cream, but I really like custard. And I eat a lot of custard in the summer. Right? I go to Cops, I sit outside, I enjoy some. That's supposed to be summer. But in the winter, I don't eat as much custard because I don't think, oh, this would be a lovely day for some cold dessert. Well, what's the thing that's really linking these? Because technically, we could say, as the amount of sunscreen I use increases, the amount of custard I am eating also increases, right? That's a true statement. In the summer, I'm wearing more sunscreen, and I'm eating more ice cream, custard. Well, what's the thing that's really connecting these two? What's the piece that's really here? It's the temperature outside, right? As the temperature outside increases, I'm wearing more sunscreen, and as the temperature outside increases, I'm going and eating more custard. That is kind of, in a sense, our third variable t. So a graph of ordered pairs x, y, where x is a function of t and y is a function of t, are functions that are defined on an interval I of t values known as a parametric curve. So if you need, pause the video to write that down because I want to mention a couple other things. These two equations are known as parametric equations. The interval I is known as the interval of the parameter. And the parameter is t. It is that thing that is linking these two. So the interval of the parameter is a list of t values. We're going to do one example together, and then we'll do the rest in class. It says graph the parametric equation in the interval from -3 to 3. So we just noticed, or we just said that the interval is an interval of t values. And we're given two equations. X is equal to t squared minus 1, and y is equal to 2t. In order to graph this, we need to figure out what x is and what y is at each value of t, and so we're going to create a table. My table is going to be 3 values, specifically t, x, and y. T is going to go from -3 to 3, because they told us that was the interval. So -3, -2, -1, 0, 1, 2, and 3. And then I am going to plug in those values for x, which in this case, x is t squared minus 1. So let's start there. So -3 squared is 9. 9 minus 1 is 8. And because I'm squaring it, I also know that the +3 version is going to be 8, right? 3 squared is 9, minus 1 is also 8. -2 squared is 4. 4 minus 1 is 3. Also the same for +2. -1 squared is 1. 1 minus 1 is 0. Also true for +1. And then 0 squared is 0. Minus 1 is a -1. We do the same with our y. Y is equal to 2 times t. So fill in your table. Oops, I did that multiplication wrong. And now we have a list of points. Each of these is the point, example 8, -6, or 3, -4. These are points that we know how to plot, right? I can plot the point 8, -6, so I'm going to sketch this curve. 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. I guess I don't need to speak out loud, but whatever. Okay, so 8, -6. It's somewhere around there. And I have 8, +6. So I've got these 2 points. I've got 3, 4, and -4. 1, 2, 3, 4. I've got 0, 2, and 0, -2. And then I've got -1, 0. And actually, when we do this, because we only have these individual points, I'm going to connect these with straight lines in between. So I'm given this shape, and if we notice, it's actually not a function, right? It does not pass the vertical line test, but it is a relation. It's a parametric relation that we see here. Now, one thing I could notice is we have these 2 variables, t in both of them. So I could substitute one in for the other. Specifically, if I take this equation here and I solve for t, I get t is equal to y divided by 2. And if I take that and plug it in for my t in my x equation, I get x is equal to y divided by 2 quantity squared minus 1. And if I think about what this shape kind of looks like, it looks parabolic, right? It looks like parabolic. It looks like a parabola, except for that it's turned on its side. And that's what we have here, because in this case, our variable that's being squared is the y, and our variable that is not is our x, right? A parabola is y is equal to x squared. This relation is the same motion, but just switching x and y. We will look at more examples in this in class, and I will go through. If you want to pause the video and write these down, otherwise you can always print from the document online. So this is the first example we'll do together, and these are the second examples we will do together. So pause the video, and I will talk to you in class. Have a good day.